Good afternoon, everyone, and welcome back to Tech Talk Tuesday here at Treadwell. Edward Titley is my name. If you're joining us for the first time, welcome. And if you joined us before, which I know many of you have, welcome back. Appreciate your support. Today, we are having a quick chat about FRP and its use in the rail industry. And we've chosen this topic because we're gearing up for Ozrail, which is in Melbourne, largest rail event in the Asia Pacific region, 25th of November to 28th of November, which is Tuesday to Friday at the Melbourne Convention Centre. So it's always a good show. Recommend coming along. We'll be there. We'll have our display there with a structure made of FRP, including staircase, handrails, cable tray, FRP mesh grating products, and a whole variety of other things. So with that said, today we're going to run through the use of FRP in the rail industry, why FRP is of value or of benefit in the rail sector. So there's a couple of features which make it useful, and then finish off with a couple of projects, and as always, a little Q&A session where we'll answer anything, we'll try and answer, I should say, anything that we deal with today, or anything else related to FRP, or anything else you'd like to ask, I guess. So without any further ado, we'll kick off. So FRP in the rail industry, why FRP? So there's a couple of motivators in rail to consider FRP. Before we look at those, we'll just have a brief overview of the applicable standards. So often, this is not exhaustive, by the way, obviously, but often we're designing structures in relation to AS 1657. So that's back of house maintenance type stuff, platforms, ladders, stairways, those sort of things. We might be considering AS 4586 compliance or testing to AS 4586, which is in regards to slip resistance. So standards for slip resistance and fall prevention. And FRP with the anti-slip surface offers a very good solution in that sector or in that requirement. And lastly, AS 1170 as far as structural design goes. We might also consider AS 1428, which is disability access, if we're dealing with something front of house, such as a platform surface or something like that. We've got webinars on many of those standards. You're welcome to find them on our YouTube channel or on our website under the resources section. You can view previous sessions we've done on some of those topics. Now, why FRP? A couple of reasons. One, we'll start off with FRP is lightweight. This is a rule of thumb, so don't rely on it exclusively, but as a rule of thumb, equivalent structure for equivalent structure. So that's equivalent performance, not equivalent size of members, because they're not always a direct swap. Equivalent structure for equivalent structure, FRP will reduce a structure weight by typically 40 to 60%. So great weight savings. Why is that an issue in rail? A couple of reasons. Obviously, we've got overhead wiring in electrified rail. So possessions where we can get that isolated are very limited. If we can bring in a structure without cranes, heavy equipment, those sort of things, then we can do two things. One is significantly increase our construction window, because obviously we don't have to specifically, we can do work without having to isolate overhead wiring. But secondly, we can build structures much faster if we can bring something in manually and construct the structure. And we'll look at one a little bit later on in this session where that was the case. There was overhead wires that prohibited any sort of crane being used, and everything had to be brought in by hand. Graffiti resistance is another positive, especially for our fencing products. FRP, or Treadwell's FRP is internally pigment. So there's a little typo. I think that should read pigments, not paint solvent. We'll get that updated. Treadwell's FRP has color pigments integrated into the product, so throughout, which means that we're not relying on a coating for color or UV stability, anything like that. Why is that important? If someone comes along and sprays graffiti onto a fence, if we have a steel structure that's powder coated or painted or something like that, we need to be very careful removing that graffiti, because we don't want to damage that coating. If we damage the coating, the structure will be liable to corrosion and shorten service life. With FRP, because it doesn't need that coating, we can high pressure blast it. We can use a paint thinner or paint remover type product to wipe off that graffiti a lot faster, cleaned up, um, and not damaging the integrity of that particular item, whether it's fencing or something like that. Often fencing gets graffitied, but not always. So easy to remove graffiti without damaging the structure. We've had good feedback from cleanup crews, especially around our substation fencing on that front. And lastly is the non-conductive aspect. FRP is non-conductive. Now, electricity is obviously pretty critical to the operation of most worldwide rail networks. Have to take some care in that electrical environment to ensure everyone's safe. So, earthing and bonding is typically what we do to prevent a touch potential and various other things. I'm not an electrical engineer, so I won't try and explain the detail of it. However, I'm sure many of you in the rail who are on the rail sector are well familiar with earthing and bonding. Now, that's time consuming, has to be done once the structure is installed. I had feedback from a client a little while back saying that they were looking at a FRP fence for their substation as opposed to traditional chain mesh fencing material. And they said that the cost of the fencing was one aspect, but the earth loop in the ground around the fence to allow it to be earthed and bonded um, actually costs more than the fence itself. So some cost savings to be had there, some time savings to be had with the install, and also some improvements in safety, given there's no possible risk of the structure having any stray currents becoming live, giving someone a tingle or an injury or something like that. So another benefit of FRP. Few access solutions in the rail corridor. This is one we did for the Northwest Metro in Sydney. These are fire hydrant and access in the tunnels. You can see the fire main, you can see some GST, and then we've got this full FRP structure as a means to get up and do anything we need to do on the fire main. So maintenance or even some emergency egress to help someone get up out of the viaduct and off the train if anything's gone wrong, they need to get out. This is another good example. This is a full FRP handrail. A couple of sites we've done a similar solution to this for, where we bring the trains in for some maintenance inside the building. We go to an FRP handrail, it's lightweight, so it can be removed when the train's in, so we can do any maintenance we need to do on it. But there's also, it's non-conductive, so there's no issues there. And you'll also see the yellow strip. This is a product we supplied for two main reasons. In hindsight, FRP grading would have been a good solution, but the steel grading was already installed. So after that, we applied this 3mm thick top plate to do two things. One, stop dropped objects through the steel grader, and secondly, prevent any issue with the body of the train being earthed out into the platform with a torque wrench or a large spanner or something along those lines, which was a concern. So that fixes those two issues. This should be a nice quick one today. So hopefully, since you've run over time the last few sessions, we can reward everyone for your patience and forbearance by being short. This is a project we did for Northeast Program Alliance for Rosanna. Now, this platform on the station walking surface, this is all FRP. This is they had tread slab product, so it's interlocking intruded deck board, good for larger spans, at least typically 2-3 meters span at 5 kPa loading, sometimes higher depending on what product you select. Why FRP? Often these platforms are concrete, as we would know. Now, a couple of reasons. This is an extension to the platform. Now, there were some services underneath, cables, conduit. I think there might have been a water main, something along those lines underneath here. Client didn't want to put concrete in for the sake of having difficulties if anything happened. If those services needed any maintenance, they have to do a lot of invasive work, cut the concrete, dig it up, and so on. So we supply this interlocking board where one central panel can be removed without the removal of adjacent panels. So it's an interlocking board with a tongue and groove sort of arrangement, but it's designed so that if I have, say, 4 panels adjacent to one another, so side by side, I can remove one of the middle panels without having to remove the outside one. So if there's any maintenance access needed to these services, the client is able to do a very non-invasive removal process to do that, get that access they need, and then simply you reinstall and reinstate that platform. Also, had a P5 slip rating, which resolved any concerns around slipperiness of some materials if it's wet or something like that. This one here is Sydney Trains substation from memory. This is a lift shaft. So the secondary structure, the primary structure is steel, but the secondary structure is FRP. That was for a couple of reasons. One was proximity to overhead wiring, and the fact that FRP is a very, very poor conductor of electricity. So that helped out with that. And also, they wanted a low maintenance, weather resistant cladding or appearance on the outside of this lift shaft. So these members we can see here, these channels with the planes of the channel facing outwards, they are FRP. Caulfield substation, this is one of our fencing products. This is a complete FRP fencing system. Client here was having some issues getting the isolation distances they needed to be able to use a steel fence. So FRP fencing resolves that in the sense that because it's non-conductive, we've significantly reduced our likelihood of arc flash, stray currents, those sort of things. So we can condense the footprint of the substation. We can also install the panels with a smaller crane because they're a lot lighter. In this instance, I think just a truck-mounted crane, a hire, was used to just lift these panels in, so a lot smaller than having a larger crane. And this is where the graffiti aspect came from as well, being able to clean off the graffiti very easily without any damage to the FRP. And then nearly finished. This is some prep work we did at a couple of locations. This is Wollongong. We also did these at Waterfall, and there's also some more at Blacktown. There's a few locations around the network where we've done these structures called an ESAP. Now, ESAP is an elevated safe access platform. These are used when the trains are in the stabling yards to facilitate cleaners getting on, be able to clean the trains, any other staff getting on and doing any maintenance they need to do on the trains. Now, you can see here where we're located. Two reasons FRP was chosen here. One is the obvious one, which is the earthing and bonding aspect, obviously very close proximity to the overhead wiring. Second was a constructability aspect. Now, this here is a refuge loop that you can see. That couldn't be power, that couldn't be isolated, couldn't be taken offline. So it wasn't practical to try and bring in a metallic structure like galvanized steel or something like that and construct that there because of the weight of that structure. This is all FRP. Posts, structural members, handrail, floor grading, everything is FRP. And this was brought in, we pre-drilled, prefabricated, pre-cut everything. So it was like a large Meccano set. However, everything was brought in manually on these concrete footpaths and brought in and installed that way, which meant that the client was able to there was about 30, I think, of these, 30, 35, something like that, of these structures now built in about 13 days. So nice fast install, but also no heavy equipment required. It was all able to be brought in by hand. So good outcome there for the client. That's the end. We hope to see you at Osrail. Looking forward to that show. It's always a good one. Always interesting to see what sort of innovations and things we have in the rail sector. As I said, Tuesday 25th to Friday 28th of November, which is very fast creeping up on us at the Melbourne Convention and Exhibition Centre. It's a good show. Glad to see anyone who wants to come along. If you'd like to set up a time to have a detailed chat, feel free. And we'll have some staff around the show, including myself, and we'll be around Melbourne CBD as well. If you'd like to set up a presentation or a session in person with your team, be happy to pop in during that time or a different time and do that as well. And lastly, it's 1:44 here in New South Wales. Stay online for a minute or so. If anyone's got any questions about anything we discussed today, feel free to reach out to put them on the Q&A window, or else anything else about FRP. Can't claim to answer everything, but we'll have a go at answering your question. Or feel free to drop us a line, hello@treadwellgroup.com.au, or give us a call, 1-800-246-800 in Australia and 0800-244-600 in New Zealand. Doesn't seem to be any questions. I'll just stay on another minute. It's 1:45 now, but doesn't seem to be any questions. So I should also add, hello at treadwellgroup.com.au. Please also send through any webinar ideas you'd like, or any feedback on webinars, good, bad, or ugly. Any feedback is appreciated. If this was a waste of time, we'd like to know and how we can improve it. If it was worthwhile, then that's good too. And we'd like to hear that. And as I said, a lot of the topics we discuss on these sessions are suggested by people like you who attend. So appreciate your support, and doesn't look to be any questions. So good day, Mark. Got a question for us? Prevent water ingress. Are you thinking through a product like you wanting a sealed walkway platform or something like that, or are you thinking into the actual product physically itself? If you're thinking through a platform, there's a couple of options around our interlocking profiles that do well to provide a proper water seal. If you're thinking around perhaps cut ends of a product or something like that, after it's cut, there should be a resealing treatment applied. It's typically a brush-on treatment, which we can provide with the product. It's a two-part system, mix up the parts and brush them on, and that'll prevent any moisture ingress into the product. It'll give you the best possible service life, especially on cut ends and those sort of locations. Into the product, righto. If it's had some scratching or vandalism, same idea. We supply, we make a sealer kit, which is available in 500 gram or 1 kilo kits. If you're just looking to do some touch-ups, you wouldn't need very much at all. You just mix the two parts together and then brush it onto the affected location. If it's a widespread area, then drop us a note and we'll see if we can find a more time-effective method to apply something or a better solution. But if it's a small scratch, scuff, abrasions, chip, something like that, then just a brush-on treatment. And with the Treadwell product, because we've got our integrated colours, you'll also note when you brush that on, you'll restore the darkness or the colour appearance. If you see a cut edge, often it looks a little bit lighter. Scuff looks a bit lighter than the surrounding product, so brushing on that treatment will restore the colour to more like the original colour. Not sure if that helps. How far water penetrates through capillary action depends on the product. So products that are pultruded with more glass in them versus resin will have different water ingress to a molded grating product, which has less glass, more resin, and also depends on resin types. Vinyl ester resins, for example, and epoxies are a lot more resistant to it. So, pretty vague answer. It depends on your product type and your resin and the situation. If it's just rainwater or something like that, be a very slow process. If it's immersed in a fluid, water, sewage, something like that, some sort of process liquor, then if it's immersed, you'll see a lot faster ingress. I don't know if that makes sense. If you've got a specific application, you're thinking about any photos or anything like that, just flick it through hello@treadwellgroup.com.au and I'll have a look. One of the team will have a look and we'll see what we can do to give you a solution. If that's all, thanks everyone for joining. See you again in a couple of weeks for another Tech Talk Tuesday. Keep your eyes out for the link to register and hopefully see you all at Oz. See, well, as many of you as you can at Osrail. Thanks for joining and have a good rest of the day.